Hi, my name is Layla Laney, and this is Test Wrapper 1. Okay, question 1.3. You must place an additional charge plus Q somewhere in the xy plane to make the net electric field at the origin be zero. Where do you put it? So for this problem, I missed 3 points for an error in my calculation of the R vector. So as you can see with my work in the answer key, they're not too far off. I think it was somewhere in my work I kind of did a big thing wrong. So maybe calculating the electric field of the charge was wrong. Because as you can see in the answer key, they set the electric field of the plus Q charge equal to the negative of the E net that we calculated in the previous part. But in my part, I set the new electric field equal to the net that we calculated in the old part plus the electric field of the point charge. And so, because I set it up that way, along with maybe some mathematical mistakes, that's what led me astray. But the main physics concepts are there. Like after that, I calculated the magnitude, r hat, and all that stuff. Like how you normally would. It was just some clerical mistakes. Okay, so question 1.4 says, assuming you place the third charge correctly, what is the direction of the net electric field you will observe at point 0 y 0 on the positive y-axis where y is greater than d? So for this part, I missed 5 points because it was just incorrect. And I knew this was going to be incorrect because the previous part that I just went over was incorrect. So my net electric field, of course, is going to be in the wrong direction, but the correct direction is going to be in the y direction because it's a monopole with a point charge. So they're all the same charge and then one is different. So that's all. Okay, question 2.1 says, use the symbols Pn, Ps, Pe, Pw for the dipole moments induced in the four atoms. Write an expression for each of these moments in terms of P, D, alpha, K in an appropriate unit vector. Ignore the effects of each polarized atom on any other atom. So for this question, I missed 1 point due to a sign error. So as you can see, in my Pn and my Ps, since those two are the same, I accidentally added a negative sign on top of the fact that x was in the negative direction, so that made that positive, which is wrong. But everything else is correct. Alrighty, so question 3.1 says, consider three collinear points A, B, and C, and a positive charge Q is shown in the schematic below. Point B lies within the thick wall of a metal container, whereas point C lies in the empty container interior. So as you can see here on this part, I missed 4 points due to two bad arrows. So the two bad arrows are located on points B and C. I did clearly indicate that the net electric field is zero for both of those points, just because it's a metal container and it's a conductor. But I should have indicated the arrow going in the opposite direction for E pole, but I have those both going in the same direction, which will actually make the net not zero. So that's where I messed up. All right, so question 3.2 says, now let's assume that points B and C lie inside an electrically insulating block of plastic as shown below. So for this question, I missed 2 points because of one bad arrow. So as you can see in the middle point of the plastic block, plastic is an insulator, so the electric field inside should not be zero. I did correctly indicate the net electric field and the electric field due to the charge, but I did not correctly indicate the E pole. That should have been pointing in the opposite direction, but it should have been smaller uh, than the electric field due to the charge. And so the net electric field would still be pointing to the right, which I did, which was correct. So that's why I missed that one arrow was wrong.